Okay.
Kamlesh? Okay. Intro part யாரு?
Shall I
Abdul?
start, sir? Yes, sir.
Yes, yes. Intro யாரு?
Intro நானே கொடுத்துக்கிறேன் சார்.
Okay,
தெரியல
start.
ஒன்றும் சொல்லலையே. Okay.
Okay, okay.
So good evening, everyone. I'm Abdul Kamil from the Department of Information Technology, second year. I'm from the college St. Joseph College of Engineering. So what are we going to look on today's topic is a comprehensive overview of cloud computing and then the deployment and evolution of Google cloud computing in the upcoming ages. So yeah, let's make this session an interactive one so that we don't feel boring because it's totally based on theoretical only. So I would not ask easy questions like what is cloud and what is this, what is that. Let's start with the evolution of cloud computing because that is the main topic that I'm going to explain today. One is the evolution and another one is GCP because most of us would be like having some kind of what do I say? Like all of us would be focusing only on AWS and Azure. It'll be pretty new for us to know what is GCP and to know what and all it offers. Because I was also curious to know about what GCP is because we have never like experienced it, right? Because I am basically in AWS, so my friends would also be in Azure, so it's pretty new for us. So it'll be pretty fun because it's what we're going to see today is we have never used it. So that is why we'll talk about what GCP is. So let's starting off with the evaluation of cloud computing. Okay. So how did the cloud evolve during the 1960s and 70s and all? So what happened was, though in those times during 1960s, 70s and all, the computers were so big. So what you do is you needed a separate room just for one machine. Can you imagine how big was that? So what happened was in the 1950s and 60s, people used mainframes. Okay. So does anyone know what a mainframe is here? Everyone? Can anyone answer what a mainframe is? Hello? Sarvanapriyan? Hello? Am I audible? If you can't speak, just raise your hand. No? Okay, fine. So better I'll tell it myself. What a mainframe is. A mainframe is a single big computer. So what it does is it gives access to multiple users to use it remotely. So what does it consume? It'll consume a lot of space, right? Because a mainframe is a single big computer that allows all the users to access it remotely.
Harshana,
Sounds like today.
camera off பண்ணுமா?
Yeah. Back on our topic, what the mainframe is. So it's very slow and costly. So what happened was in the early 1970s, virtualization was born. This method was pretty helpful for all those who managed through the 70s eras. This allowed multiple operating systems on one physical machine. So everyone present in that meeting would be knowing what an OS is because all the AWS projects we do, all the services that we use, it will easily ask what an OS is without knowing that you can't do even perform a single task in AWS or Azure. So in 1970s, what happened was virtualization was born. This allowed multiple operating systems on one physical machine. It's pretty cool, right? But a bit expensive too because in 1970s and all it would be so what do you say if there is one single product in that market you the value or the cost of that product would easily be high because the availability is low, right? So that is why it was a bit expensive. So jumping to the 1980s and 90s, client server architecture came in. So what is the client server architecture? It is nothing but an architecture between the client and the server. Okay. Think of this as one boss giving work to many employees. So what does a boss do? He gives works to many employees. Our computer started talking to servers for application and storage. So that is what a computer used to do in 1980s and 90s. So this process is called as client server architecture. So let me change the slide. Yeah, this is what I was all talking about, launch of AWS and all. In the year 2006, AWS was launched. So you guys pretty make a note of it because it's a pretty it's a pretty important question only because the ones who are studying AWS should know this. Okay. Then the rise of SaaS and PaaS. What is SaaS? Software as a service and product as a service. This and all began in the year 2000s, early 2000s. In 2010s and all, adoption of multi-cloud strategies came to arise. So let me see. Let me tell you guys what happened in the early 2000s. In the early 2000s and all, the real magic happened because the companies like Amazon, Google, and Microsoft said, instead of buying and maintaining servers, why not rent them from us? It's a correct point only, no? Instead of buying and maintaining servers, we can easily rent them. For example, I would say if a bachelor is coming to Chennai, okay, and he's in the starting early stages of earning money. So what does he do? Will he buy a whole house? No, right? Because it would easily cost him high, and then it's pretty. What do you say? It's basically an advantage for him to live in a rented house so that he can get all the facilities that have been available in the own house instead of paying 1 crore or 2 crore, whatever the price may be. He's renting the whole house just for a minimal amount of money for a monthly basis or yearly basis. It's totally upon the rent that we give. So the Google, Microsoft, and Amazon companies and all came to a rise in 2000s. And what did they say? They said that instead of buying and maintaining servers, we can easily rent them. Okay. And this cloud era officially began. And today we have serverless computing, edge computing, multi-cloud, making cloud faster, smarter, and cheaper. So let me change the slide. That PPT, this whole PPT is just to know about what's going on in 2000s, 2020, 2022. Okay, so someone's mic is on here. Yeah, fine. Hello. Yeah, fine. Then we'll change the slide. So yeah, let's look upon the cloud deployment models. So it's pretty, everyone must be knowing it, but that's what my task is because some of you that present in the meet have easily been completed the practitioner exam itself. So it would be easy for them to understand what the deployment models are. So let me give you a clear insight. What are the deployment models that have been present in the cloud? And I'll give a easy example for it too. Okay. Okay. So what is okay? There are three types. Wait a minute. So, okay. The deployment of cloud computing. What is it? Public cloud, private cloud, hybrid cloud, and multi-cloud. So what are they? They are easily deploying what the cloud computing does in a way of public manner or private manner or hybrid is a mix of both. Let's say you're planning a big wedding. What do? You have three options for your food catering. One is public, one is private, and one is hybrid. So when it comes to the topic public cloud, You hire a big catering company like AWS, GCP, or Azure. They bring everything, cook for everyone, and you pay based on how much you eat. That is what a public cloud is. Okay. When it comes to private cloud, you hire a personal chef at home. And what do? You have full control over the menu. But it's pretty expensive, right? Because you're hiring a personal chef at home, he would cost easily, it cost more money because you're making him private. You're buying him on a personal purpose. So that's why it is a bit expensive compared to public cloud. So when it comes to the topic hybrid cloud, you call a caterer for the main food and prepare snacks at home. It's a pretty mixture of both, right? Mixing both public and private cloud. That is what a hybrid cloud is. You call a caterer for the main food and prepare snacks at home. Balanced, cost effective, and bit convenient too. Okay. Then multi-cloud. It's a pretty fun example I'm going to say. You order biryani from one hotel, starters from another, and desserts from a third place. Okay, what is multi-cloud? You mix all those cloud models in one single. You will deploy all those cloud models in one single model is called as multi-cloud. So let me give you a professional example on a professional insight on what the real deployment of cloud computing is. So cloud computing can be deployed in various methods depending on an organization's needs, right? Yeah, there are three types of cloud models that four types of cloud models basically. They are public cloud, private cloud, hybrid cloud, and multi-cloud. So what is a public cloud? As I said before, public cloud services are offered by third-party providers like AWS, Microsoft Azure, and GCP. They are third-party providers. Okay, these services are available over the internet and allow businesses to scale without maintaining physical infrastructure. They don't maintain any kind of physical infrastructure. All they do is they are available over internet and they allow businesses to scale. So public clouds are cost effective, I would say, and highly scalable too. They are managed by their own provider. But what they do is they may have concerns related to security and compliance because when anything that comes to public, it serves everyone, right? So that is why they may have concerns related to security and compliance. Okay, everyone must have been gotten clear about what public cloud is. So the second point is private cloud. A private cloud is dedicated to a single organization. Okay, because we are making it private, we are paying high in order to make that thing private, and it is either hosted on premises or by a third party vendor. I would say it offers greater control, security, and customization also compared to public cloud solutions because obviously we are paying high for it, and we can feel bit luxurious when it comes to private cloud because we are paying a huge amount of money when it compared to public cloud. It offers great control, security, and so and so. I would suggest you guys. I would suggest public clouds are ideal for businesses that handle sensitive data such as banks and healthcare institutions and all because all they do is they secure their data, so they secure their information in order to maintain it private. Okay, finish. Private cloud finish. So when it comes to hybrid cloud combines both public and private clouds, allowing data and applications to be shared between them. It's a pretty mixture of both, right? It has all the features that are available in the private and as well as the public cloud. This model offers flexibility and more of improved security. And it's a bit optimized performance by leveraging the best of both worlds, both private cloud and public cloud. Software companies use hybrid clouds for disaster recovery, regulatory compliance, and workload distribution because everyone must experience and attend the proper workload, a distributed workload. That is what a hybrid cloud stands for. And when it comes to the topic of multi-cloud, it is a strategy where an organization uses services from multiple cloud providers This approach helps reduce vendor lock-in because vendor there would be no, how do I say, there would be no lacking of reliability and no lacking of performance because it is a mixture of multiple cloud providers, right? It enhances performance by utilizing the strength of different cloud platforms. So let me change the slide. Then everyone must be knowing what are the key benefits of cloud computing. Obviously it's scalability, cost efficiency, accessibility, collaboration, because you'll get all the services under one roof. No matter what kind of providers they are, whether it's GCP or Azure or AWS, you'll get all the benefits of cloud computing under one single provider. So it's pretty advantage for us, right, to use the benefits of cloud computing. Next chart is a comparison of cloud computing. There are three types of services, more of like infrastructure as a service, product as a platform as a service, and then software as a service. So, what is infrastructure as a service? So, let me say it by myself. Infrastructure service, it provides virtualized computing resources over the internet, right? Everything you get is virtually present over the internet so that the users can rent servers, storages, and networking on demand. For example, I would say for IaaS is EC2 for AWS and Google Compute Engine for GCP. So when I take the topic GCP during the end timing of this session, we'll get to know the core services of GCP. Like I've mentioned it now, the examples of IaaS, the Google Cloud Compute Engine. It's pretty a normal and most important service present in a GCP, like the EC2 in AWS. So what do you do in infrastructure as a services? You manage OS, applications, and all the data that has been provided over the internet. So when it comes to the second topic, platform as a service, it offers a platform for developers to build, to deploy, and to manage applications without worrying about the underlying infrastructure, the infrastructure that has been already present. Okay. For example, let's say Google App Engine, AWS Elastic Beanstalk. So yeah, this is what platform as a service stands for. You manage applications and data all by yourself. That is what AWS Beanstalk, Elastic Beanstalk does, right? So the third topic is going to be software as a service. That is SaaS. So what does it do is it delivers fully functional applications over the internet, like which are ready to use without any installation or any kind of maintenance. It will be fully functionable once it attains the internet. For example, let's say Microsoft 365. That's a software, right? Basically, you can get all the services inside it. Like there is Excel, there is PowerPoint, and so and so. There are so much of services that has been provided by the Microsoft, and also the Google Workspace. You get all those Google Drives and so much services that have been provided by the Google uh, Workspace. All you do is you manage user settings, preferences, and everything else like application infrastructure. All you do is already has been presented over the software. So this is what software as a service stands for. So let's move on to the next topic. We have already completed this topic before, classifying cloud service providers. So the next slide is going to be Google platform. Yeah, Google Cloud Platform, GCP. So yeah, this is the main topic that we are going to see today. So everyone would be like, it's pretty new for us, right? It's new for me as well as you guys too, because we have never studied about it. We have never like experienced it IRL in our real life, in our PEP class or anywhere else. So what I'm going to do is I'm going to talk to you guys about what GCP is and what are all the core services that it provides, and what are the difference between AWS, Azure, and GCP, and all those stuff. So yeah, GCP, Google Cloud Platform. So what is a GCP? It is a suite of Google Cloud computing services offered by Google. It provides computing power, storage, machine learning, networking, and security solutions to businesses worldwide. I would stress upon that point, machine learning, because when it comes to doing all those machine learning things in separate, you need a lot of tools, right, in order to access all those machine learning projects or to complete them all at once. You've got to download it all by yourself, like doing for big data, you'll use Hadoop or Kafka, Apache Kafka. You'll get all the services of machine learning all under one roof. That is where GCP excels in. I'm pretty sure that the GCP is better compared to AWS or Azure when it comes to the topic machine learning. It's pretty advantage point too, that it excels in machine learning. So yeah, GCP is known for its high performance infrastructure, scalability, security, and AML capabilities. Google operates data centers worldwide, ensuring low latency and high availability. There would be we can't experience any kind of latency over Google Cloud Computing because it is the top provider that we have been experiencing nowadays. Uh, there will be no latency, and it will be easily available. So I would say some of the key benefits of GCP includes sustainable environment and security, AML capabilities, hybrid cloud, and multi-cloud support. It runs on carbon neutral infrastructure. So I'll tell you guys about what a carbon neutral infrastructure is. It means that Google offsets its carbon emissions and actively works towards sustainability. That is what a carbon neutral infrastructure stands for. Some key benefits of it are renewable energy, efficient data centers. That is what the main point is. Efficient data centers. GCP's data centers are designed for maximum efficiency. That is where the main point the GCP excels. Carbon neutral infrastructure is pretty unique when it's compared to AWS or Azure because we don't have any kind of carbon neutral infrastructure over those two services that have been present over the few years. It also does carbon offsetting. So what does carbon offsetting means? For example, Google invests in projects that remove carbon dioxide from the atmosphere, let's say, okay, making their operations carbon neutral since 2007. So that is what the Google has been doing. So what the Google aims is it aims to operate entirely on carbon-free energy 24 by 7 by the year 2030. It's pretty impressive, right? Because that is going easily going to help all of us successors in order to preserve their resources. It aims to operate entirely on carbon-free energy 24 by 7 by the year 2030. Then that is what the carbon neutral infrastructure stands for. Then the security reason that it has is it uses Google's global scale security measures. That's pretty impressive, right? Because all we use in our phones or anywhere our laptops is Google's services only. Wherever you go, wherever you see Google Drive, Google Maps, Google this, Google that, Google take care of anything, everything that has been present over the internet. So the security reason is also the one of the best reasons that we can rely on GCP. And when it comes to the point AIML capabilities, it leads in AI innovations like it uses Vertex AI and AutoML. That's the services that it provides. Vertex AI and AutoML. We'll furthermore look on what both the services stands for and what are the key features of it. So one more advantage of GCP is it offers hybrid and multi-cloud support, so that we can induce all those cross-cloud integration in order to make our task simple, easy, finish that. Okay, simple. Let me change the slide. All we have been seeing is Google's features. So these are all the main services that the GCP platform provides. All it does is provides compute engine. So when it comes to compute engine, everyone must be knowing here, right? What is a compute engine? So let me ask the question. What are the compute engines that are provided in the AWS? It's pretty easy only, so anyone can answer. So why don't you guys give it a shot then? What is the compute instance in AWS? Anyone? Hello, am I audible?
Yeah, you are audible.
Yeah. So yeah, let me skip it then. No one is answering here. So what is a compute engine? You guys must be knowing, right? There's one there's the compute engine that AWS has is EC2. It's pretty easy only. So virtual machines and scalable computing power to run workloads efficiently. Yeah, that's right, Gopika. Thank you for response. Then cloud storage, it handles secure and durable objects. Then BigQuery, Kubernetes engine, cloud functions, additional notable services. So let us see on the key services that the GCP provides. Okay. Hmm. The first one that GCP's key service is Google Cloud Engine, Google Compute Engine. So as I've said before, what a Google Compute Engine is, it's basically a VM, that is a virtual machine. So let me tell you guys what a virtual machine is. It will be just a what you call refreshing session only. What is a virtual machine? A virtual machine is AWS is a virtualized computing instance provided by Amazon EC2. So it can host gaming servers, it can do big data processing, it can do machine learning. So some of its types are T3.micro or M5.large. What does 3T.micro stands for? Those are the types that the virtual machine provides us. Then I was talking about Google Cloud Compute Engine, right? A fully customizable virtual machine service that lets you launch and scale compute resources with ease. Flexible VMs we can use with a variety of machine types. Then it's pretty pay per use only because whatever you do, wherever you go inside the cloud computing concept, you've got to pay for it in order to use all those services. There are some services that we don't need to pay, but those are not that much effective, I would say. Because when it comes to GCP, you've got to pay for the least service that you use. So it's also scalable for high demand workloads. What is a high demand workload? It can go through uh, any kind of loads that it access, like no matter how many GB or how many TB it consists of, it is pretty scalable, that I would say. It's like a renting computer so that whenever you need it, no maintenance, no worries, that's it. You rent it, use it, boom, finish, that's it. So that is what Google Compute Engine gives us. So the next point is going to be Google Kubernetes Engine. So everyone here. So I'll self tell you guys what Kubernetes is. A Kubernetes is a kind of DevOps tool that helps us to deploy and manage containerized application. So what does a containerized application stands for? When it comes to the topic containerized application, you containerized all those applications. Like for example, we take a VS Code project, right? I'm building a website. So what do? I have all of my HTML files. If I'm performing that website in my markup language, in my wish, like I'll use HTML, CSS, or JS. So what do? I'll put all those under a single folder, and I'll containerize my set of codes so that so that it doesn't get lost, or so that I can easily access all those codes by just going inside the folder. That is what a containerized application stands for. So Google Kubernetes Engine. GKE. That's a pretty, what do I say? It's used for deploying or managing the containerized applications. So its applications are it is automatic scaling and self-healing, so that it will keep our containers running smoothly. It can be easily integrated with GCP servers also for a seamless experience, so that we don't feel or we don't experience any kind of latency or lagging over the services that we use. Kubernetes handles the hard work while you focus on of scaling think. Think of it as the manager of your app's infrastructure, because whatever you do, wherever you go, whatever thing you deploy on your app, you can't do it with the help of without the help of Kubernetes engine. So that is what Kubernetes stands for. So the third service that GCP provides is Google Cloud Storage. So everyone must have got to know what the Google Cloud Storage stands for. It's pretty easy only. Cloud Storage for large-scale data, offering high durability and various storage classes. It's scalable so that it can store everything from files to videos A to Z, no matter how big it is, or no matter how many TB it contains. And it's pretty ongoing with all kind of big data sets. So it has multiple tiers to for different data access that we need. Google Cloud Storage is like an unlimited digital locker. So what do we do in a locker? We put all of our belongings, all of our things that uh, mean to our so and so ones. We put them in a locker for better security and better safety for our data. So that's what we do in our Google Cloud Storage too. It's also called as unlimited digital locker. I'd like to stress upon that point, unlimited, because you can store enormous amount of data over that digital locker. Then the fourth service that I'm going to talk about is Google BigQuery. A BigQuery is a serverless, scalable data warehouse designed for real-time analytics. So what do we do? We analyze all the data based on the real time. It's so data warehouse. What is a data warehouse? So data warehouse is a place where you store all those big big data, and it can easily be accessed to when we store something in data warehouse. Without our knowledge, we can't store it, right? Without where we are going to store, or it will be easy for us to even to access those big data. Some advantages of BigQuery is instant queries on massive data sets. So what do we do when the data set is massive? Obviously, it will take us more time to analyze the data, or like work on a single set of code. So it's pretty easy when it comes to the topic BigQuery, so that you can instant query over the massive data sets. It is fully managed to focusing on analytics, not only on maintenance. So what does a BigQuery do is it takes your data, analyzes it from slow and painful to instant and effortless one. So what does it do? It takes your data, analyze it with a slow process to an instant and effortless one. So next service, what we're going to say is Google Cloud Pub or Sub. So what does a Google Cloud Sub stands for? That is a messaging service for building event-driven architectures. Event-driven architecture means the architecture would be totally deployed or created or built based on the event. So once the event gets over, that's it. We are closing the architecture too. That's what the Google Cloud Pub stands for. It supports across multiple distributed systems, and it is ideal for real-time data flow like IoT or logs. So whenever you're going to introduce an IoT over your software, you've got to use Google Cloud PubSub if you use the GCP service. So imagine sending an instant notification to users without overloading the system. That is where Google Cloud Sub acts really. So the next service that I'm going to talk about is Google Cloud Firestore. What is the Google Cloud Firestore? It is a NoSQL document database for real-time syncing of data across devices. So that is what it stands for. It's pretty flexible and automatic synchronization too, because we don't have to do anything manually to synchronize the data, the real-time analyzing and all. So Firestore keeps your data synced across devices in real time, just like your favorite team collaboration app. You must have done no in all of our guys are in second year. You must have obviously we created a website or deployed an app. It's like that only. Then the next services, the seventh services, Google Cloud AI and ML tools. As I've told you guys before that I'm going to talk about AI and ML tools. I've already mentioned that the main services when it comes to AI ML in GCP is Vertex AI and Auto ML. So what are they are? Those are a range of tools to build AI ML models, that is artificial intelligence and machine learning models, and integrate their smart features to our software. So when it comes to Vertex AI, it is a service that has been provided by the GCP in order to perform all of our ML operations with our project that we are doing. So Vertex AI, it manages the entire machine learning life cycle from A to Z, whatever we do in that machine learning, from where to start, from where should I end, everything A to Z. The Vertex AI manages it. So although also a famous or a great service that I would say is AutoML that has been provided over the internet for so many years that GCP offers is AutoML. It builds custom models without code. Can you even imagine that you are creating an ML model with zero code, no code? That's it. You are using zero code and you are creating ML model, and that can be only be done by AutoML. And that AutoML service is provided by GCP. Then Vertex AI. Vertex AI lets you train models as efficiently as you can order a pizza. Everyone must have got to know like how easy it is to order a pizza or cook or deliver the result in minutes. Yeah, that is what AI ML tools in Google Cloud stands for. And the next service is going to be Google Cloud Networking. So networking services to ensure it is a networking service that makes sure secure and fast connections. That is what GCN, which is basically Google Cloud Networking, stands for. It does all those works related to networking things. Like when it comes to VPC, we must have heard, right, in AWS and all, VPC, Virtual Private Cloud, what does it do? It isolates resources securely because it's a private one. We are paying a high amount for it in order to get all the benefits from it. So also cloud load balancing is also it does so that it distributes all the traffic efficiently inside the Google Cloud Networking. And also a new service that I would like to tell you guys is Google Cloud Identity and Security Tools. What it does is it manages the identity and access control. As you guys must have heard this topic in AWS. I'm not pretty sure about Azure thing is. I'm personally AWS, so I'm telling that this services in AWS has been performed by IAM, which is basically Identity Access Management. So what does it do? It manages identity and access control with robust security service. Robust means with the best security service that has been provided over the internet. So it'll easily do encryption, decryption process. So what is encryption? Encryption is something that you have a data on your hand. To secure the data, to safeguard the data, you are you are converting that data into a single set of code so that you can keep it safely with a lot of security. That is what encryption stands for. And the total vice versa process is called as decryption. You are converting that code into that data that has been already presented. So that is what encryption decryption stands for. And Google Cloud Identity and Security tools easily does that. Okay, then additional services are Cloud Spanner, Cloud Functions, Cloud SQL, and Cloud Monitoring. And all of these services are provided by the GCPs. And that's it, wrap up. From compute to storage, machine learning to networking, GCP offers a full suite of services to build, to deploy, and to scale our applications effortlessly. It's like a smart assistant, I would say, because it covers all the infrastructure, it covers all the services that AWS and Azure lacks of. So that is what totally about GCP is the services that I'm going to talk about with this topic. So let's have a recap of what we have seen today, and after this, we'll compare it with AWS, Azure, and GCP so that we can have a takeaway on what and all do we have, what and all the unique features do we get to experience in our particular field. Because I'm doing AWS. Then I was pretty curious, because we are going to study about GCP. What is the difference between GCP and AWS? What and all the unique features that AWS has and the GCP lacks? So we'll see that in the end of this session and wind up this session. So let's have a recap. We have been discussing about the evolution on how cloud has begun and how cloud computing has drastically changed over the years, like influencing technology and business practices. From evolution, we have had a look at deployment models too. I've given a simple example referring that chef that catering services to understand better on the cloud deployment models. So advantages also we saw about all those uh, the types of cloud, then the deployment models of cloud, then types of services also we saw explaining about infrastructure as a service, platform as a service, and then software as a service. Then GCP. I gave you guys a clear explanation on what GCP stands for and what are the core services that it provides. So that is what this session was all about. So let me present you guys what is the difference between AWS, GCP, and Azure, so that you guys can get a clear view on what are the unique features that we are studying on a day-to-day life. So just give me a single minute. I'll present that image over to you guys. Is my screen visible? Anyone? Everyone? Just raise your hand. Thank you. So yeah, let's look on the core services that AWS or Azure or GCP provides. The main available regions that AWS has is that we have AWS regions and zones, and in Azure we have Azure regions, and in GCP all we have is regions and zones. So as I was talking about computing service, AWS has EC2 and Azure has virtual machines. And when it comes to GCP, Google Compute Engine is the computing service that has been offered by the GCP. And when it comes to hosting an app that you've been created by yourself in AWS, that we do is AWS Elastic Beanstalk. All of you guys who are doing AWS must have got to know about what AWS Beanstalk stands for. Then for Azure, there is Google Azure Cloud Service, and for Google, there's one Google App Engine. So yeah, that is what Google Cloud Platform offers us for hosting our apps. For serverless computing, AWS Lambda, it's pretty important topic when it comes to studying or preparing for a AI practitioner, because that's the main thing. That's one of the most important topic that has been present to in order to prepare for our practitioner exam. So in Azure, we have Azure Functions. In GCP, we have Google Cloud Functions for container support, for containerizing an application or something else. As I've told you guys before, In GCP, there are two tools provided. One is Kubernetes engine, and another one is Docker. So as I've told you guys before, what does it stands for? What does containerized application stands for? I've given you guys an example too. We are going to develop our own website. What do we do is we create a folder. All we do is paste or save our files, save our HTML files or CSS files in one single folder. So what do? We containerize it in order to access it easily, so that we don't have to go and search for a single file here and there. So that is what containerization stands for. And when it comes to GCP, a high-level containerization has been done by those services that have been provided by Kubernetes and then the Docker. So next is scaling option, and AWS provides auto scaling. And when it comes to Azure, there is Azure auto scale. In GCP also there is auto scaling. For object storage, there is Amazon Simple Storage Service. That's the basic first and foremost thing that we study when we step our legs into this AWS whole AWS thing, right? Whatever you do, you can easily use S3 in our own projects, right? We can do all the stuffs when it comes to AWS S3, right? So give me a single minute. So yeah, for example, even I did a project on web development for inducing cloud with my project for the storage purposes. I used S3 particularly. So what do I do in S3? If someone is registering their details, if someone is logging in, if someone is doing something that has to be saved in order to not let that go in that internet. So what do? Is we integrate S3 with our login button. So what do we do is if someone logins our page, our website, they put all those credential. If they click that login button, automatically it will navigate their login credentials, all the data into our S3 server. We've got to pay for it in order to access all its benefits. So that is what I was saying about the S3, Amazon Simple Storage. So that's pretty basic. When it comes to Azure, that is Amazon Azure Blob Storage, and for GCP, it's also basic only cloud storage. Then block storage, there is EBS in AWS. Everyone must have known about what EBS is. We are running out of time. That's why I'm not able to say a single services and all. In Azure, there is Azure Managed Storage, persistent disk in GCP. So content delivery, this is the main service that we use when it comes to AWS in order to deliver our content. It's pretty an important observation abbreviation for CDN2, Content Delivery Network. So what do we do in Amazon CloudFront? We deliver all of our content that has to be provided to our end users through our software. So we use this service in order to get that content delivery network process happening. For Azure also there is CDN only. For for GCP also it is same. When it comes to SQL database options, Amazon has its own relational database systems. And when it comes to Azure, it uses SQL database. So in cloud also there is a cloud SQL. This whole thing, what I'm doing is just to what do I say? Compare on what the services that the AWS, GCP, and Azure offers us to use a single. So if someone is using virtual network, okay, and he is using Azure, so that he can easily compare the networks that has been provided by Google as well as Amazon. That is what the whole agenda is. So when it comes to virtual network, we use VPC in AWS, and in Azure we use virtual network. In cloud, it is also the same too. For private connectivity, we use direct connect. For an established and secured connection, we use AWS direct connect. For Azure, there is express route that we use in order to get our private connectivity happening. Then cloud interconnect when it comes to GCP. So yeah, that is what this session was about. Yeah, our main takeaway on this session was the deployment of cloud models and then the evolving of cloud, and then what is GCP and what are the core services that the GCP provides us. So I'll share this image in our group itself so that everyone must be knowing the differences between the AWS, Azure, and GCP consoles that the services they provide. So that is what it was all about. So yeah, feel free to give a feedback on how the class was in the group. So yeah, that's what this session was all about. So Sayana, okay, thank you for a thumbs up, Joshua. Hello, anyone?
Thank you, Abdul. It was wonderful
Okay,
session.
pleasure, my pleasure.
It was a wonderful session, Abdul.
Okay, thank you, Sarana. Means a lot.
Is there any question to ask?
Very good and very informative, Abdul.
Okay, thank you, Joshua. Means a lot.